Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So the topic that we will discuss today it is the determining oxidation state of an unknown element. So for the determination of the oxidation state, we must know the group number of that element. It will be helpful for this. Second thing, we must know that how many electrons it can lose when it is having the combination with any other element in any type of the compound. So these two things must be in our hands to determine the oxidation state of an unknown element. On the other hand, when we are going to determine that oxidation state, we must know the valency of an element, that what is the main valency of an element, because in the previous we have learned basically the four rules of the oxidation state, in which one we have learned the oxidation state of free or uncombined elements. Then we learn about the oxidation state of the ions. Then we learn about the oxidation state of the neutral compounds or the stable compounds. And the fourth one rule about the oxidation state of the complex ions. And these complex ions are also known as the molecular ions. So we have learned these four rules. To determine the oxidation state, we must keep it in mind, these four rules, for this purpose. So let's have a look on this. First of all, you must know the what oxidation state means. Basically, oxidation state is the apparent charge that an atom will have in a molecule or in a compound. Molecule in a compound, or it may have when it is present in the form of ions. So, oxidation state, its scale is from 0 to towards the positive end and towards the negative end. So basically, when any atom lose more electrons, it is more oxidized and less reduces. So free elements have zero oxidation, so there is no loss or no gain of the electrons. But on the other hand, when an element is going to gain more electrons, it will be less oxidized and more reduced, because by the gain of electrons, it is undergoing oxidation, it is undergoing reduction, so it will be reduced more and it will be oxidized less. And here it will be oxidized more and it will reduce less. In oxidation state, the positive charge will be increases, and in reduction state, the negative charge will be increases. Now let's have the two examples for the purpose to identify or determination of the oxidation state. Here we have an example in which we have to find the oxidation state of the nitrogen in HNO3, when the oxidation state, the number of the hydrogen as +1 and of oxygen we have -2. Now here we have the given data, the oxidation state of known elements. The first one is oxygen is equal to -2, and for hydrogen we have +1. So, and the oxidation state of nitrogen that we have to find. So we will simply learn that the oxidation algebraic sum of oxidation state of neutral element is always equal to 0. So we will take here their algebraic sum and it will be equal to 0. Now just have a look. First of all, we will write that compound. It is HNO3 and oxidation state algebraic sum is equal to 0. Here the oxidation state of hydrogen is +1. Then algebraic sum of nitrogen that we have to find. So we will put it as X. And then we have the algebraic sum of oxidation state of oxygen, which is -2. Multiply it with 3 because there are 3 atoms of oxygen present. Now +1 plus X plus -3 -2 multiplied by 3, we will have -6. It is equal to 0. By solving this equation, -6 and +1, we will gain here -5 plus x, which is equal to 0. Now this x and the 5 will move over there and it changes into the plus 5. So the oxidation state of nitrogen here we have plus 5. Now let's find it out hydrogen, nitrogen and oxygen 3. The oxidation state of hydrogen plus 1, nitrogen plus 5, oxygen minus 2 and multiply by 3. This is minus 6, this is plus 6 and its algebraic sign will be equal to 0. So this is a simple way to determine the oxidation state of an unknown element. There we have the second example for the determination. Here we have to calculate the oxidation state of sulfur in H2SO4 when the oxidation number of hydrogen is plus 1 and oxidation number of oxygen is minus 2. So first of all we have the oxidation state of the given, which is the hydrogen. We will take plus 1 and oxygen is equal to minus 2, and the oxidation state of sulfur that we need to find. Now start calculation. H2SO4, their algebraic sum is equal to 0, from where the oxidation state of hydrogen we have plus 1. Multiply it with 2. Then we have plus the oxidation state of sulfur that we have to find. Then we have plus the oxidation state of oxygen is minus 2. Multiply by 4 and it is equal to 0. Now by solving this, plus 1 multiplied by 2 we will gain here plus 2, then plus oxidation state of sulfur, and here we have then plus minus minus 2 fours are 8, which is equal to 0. By solving this, here we gain sulfur minus 6 is equal to 0 and sulfur is equal to minus 6, and on the other side it will become plus 6. So here the oxidation state of sulfur is plus 6. Likewise, H2SO4 plus 1 multiplied by 2 plus 6 and minus 2 multiplied by 4. This is plus 2, this will be plus 6 and this will be minus 8. So plus 8 and minus 8 algebraic sum will be equal to 0. So this was all about today's lecture. I hope you guys understand and you just keep practice on the oxidation number and its determination. If you have any queries, you may ask me about that. And the next topic that we will discuss it is the oxidizing and reducing agents. For that time, you guys keep learning and have a good day.